Welcome to Functions. This unit is the absolute bedrock of Pure Mathematics 1. Everything you do later in calculus, trigonometry, and beyond relies entirely on the grammar you learn right here. We are moving past simple algebra to look deeply at how mathematical relationships behave. You need to know exactly how they map inputs to outputs and how we can manipulate them both visually and algebraically to solve higher-level exam problems. First, we clarify exactly what makes a relationship a mathematical function. You will learn to confidently spot the difference between one-one and many-one mappings. Only specific mappings earn the title of a function, and mastering this formal definition is your first crucial step to securing those early Paper 1 marks. You will also become fluent in reading and writing formal function notation, which examiners use to set up almost every question. Next, we define the boundaries of these functions. The domain is the set of all allowed inputs, and the range is the set of all possible outputs. You will learn how restricting a domain physically chops a graph, completely altering the range. Examiners love testing your ability to find these limits algebraically by completing the square, or by sketching the curve to see the maximum and minimum points directly. Then we start combining them into composite functions. A composite function feeds the output of one function directly into the input of another, creating a chain. You will form expressions like f of g of x and quickly discover that the order of composition matters completely. Doing things in reverse gives a totally different result. You will also learn how to find the precise domains for these new composites, a heavily tested skill that acts as the silent workhorse behind the calculus chain rule. Not every function can be reversed. You will learn the golden rule. A function must be strictly 1-1 to have an inverse. We will find these inverses algebraically by swapping x and y, and graphically by reflecting the original curve in the diagonal line y equals x. You will be able to map asymptotes and intercepts instantly using this visual symmetry, often bypassing heavy algebra entirely to grab quick marks. Finally, we tackle the modulus function. Written as the absolute value of f of x, this is not just a magic button that makes numbers positive. It represents a geometric distance from zero. You will learn to sketch complex absolute value graphs by reflecting negative portions sharply above the x-axis. More importantly, you will use these graphs to solve tricky modulus inequalities that would otherwise require pages of messy casework, a classic trap in Cambridge exams. By the end of this unit, you will have mastered the core language of A-level mathematics. You will comfortably define domains, combine multiple functions, find their inverses, and sketch modulus graphs with absolute precision. These algebraic and graphical tools are the engine of Paper 1, and you will use them in almost every topic from now on. You are ready. Let us dive in.